Welcome to Insight Hub, the video series dedicated to the world of data and brought to you by Miracles Data Practice.
Hi, this is Amrita Rapatti, working as a Data Science Research Associate at Miracle Innovation Labs. In this video, I am going to talk about predicting the severity of lower back pain using AutoML in H2O.ai. Here is the agenda. We will be covering about introduction to H2O and algorithms available in H2O. And then we will talk about what is AutoML in H2O and what are the different aspects and functionalities included in H2O's AutoML. Finally, we will discuss about overview of use case followed by live demo. Now let's have a small talk on H2O.ai and H2O. H2O.ai is the company which makes ML easier for all, and their open source community includes more than 129,000 data scientists and 12,000 organizations. The products of H2O.ai are Sparkling Water, Driverless AI, H2O for GPU, Enterprise Stream, and H2O. Sparkling Water allows users to combine the fast, scalable machine learning algorithms of H2O with the capabilities of Spark. Driverless AI is a high-performance GPU-enabled computing platform for automatic development and rapid deployment of state-of-the-art predictive analytics models. H2O for GPU platform inherits all existing scikit-learn algorithms, and it is 5 times faster on GPUs as compared to CPUs. Enterprise Stream is a service for securely starting and connecting to H2O yarn jobs in a Hadoop environment. H2O is an open source distributed in memory, machine learning, and predictive analytics platform. Its core code is written in Java, and this platform provides interfaces for R, Python, Scala, Java, JSON, and JavaScript or CoffeeScript, along with a built-in web interface. It supports most widely used statistical and machine learning algorithms. Here are the list of supervised and unsupervised algorithms available in H2O. Now let's have a discussion on AutoML. AutoML is a functionality in H2O that automates machine learning workflow, which includes automated training and tuning of many models within a user-specified time limit. It is also a kind of data science pipeline with the goal of finding the best model with the least amount of effort. Here is the flow of AutoML, which includes loading the training test dataset, specify the response column, which is output column that we are going to predict. Run the AutoML by specifying the stopping criteria. There are two stopping strategies, which are max runtime seconds and max models. The max runtime seconds argument control how long the AutoML will run before training the final stacked ensemble model, and its default value is 1 hour. Max models specify the maximum number of models to build in an AutoML run, excluding the stacked ensemble model, and its default value is 4. There are also several other optional parameters which can be set, example and false, balance classes, class sampling factors, and so on. Next, we can view the AutoML leaderboard. The AutoML object includes the leaderboard of all models that were trained in the process, including the 5-fold cross-validated model performance. The AutoML as a stacked ensemble, which is all models ensemble. The all models ensemble is ensemble of all individual models in the AutoML run. This is often the top performing model in the leaderboard. And finally, we will predict the data using ladder model, which is best model, and save the ladder model. And also you can download the model and use it for deploying it to production. Here are the 3 aspects of AutoML, which are data preparation, model generation, and ensembles. In data preparation, all H2O algorithms has automatic data pre-processing, where imputation is handling of missing data. One-hot encoding is representation of categorical values as binary vectors. Standardization is rescaling of data to a mean of 0 and standard deviation of 1. Feature selection is choosing the subset of features. And feature extraction is taking set or all features, which are reducing or expanding your feature sets. Example, principal component analysis and dimensionality reduction algorithm. And count or label or target encoding of categorical features is different types of encoding of categorical features. In model generation, there are a number of different ways we can generate set of different models automatically. Example, random research, Bayesian hyperoptimization, and so on. And here ensemble is, instead of choosing the best model, you can take all the models or some subset of models. Ensemble performs particularly well if all models are basically strong and make correlated errors. Getting the best model out of all the generated models, which most of the time is an ensemble. Example, ensemble selection, stacking, and so on. Here are the functionalities of AutoML, which includes basic data preparation, which will be handled automatically by H2O algorithms, trains random grid of algorithms like graded booster machine, generalized logistic model, deep random forest, XGBoost, and deep learning in AutoML. In coming to random research, it is much faster when we have large number of possible combinations of hyperparameters and find sufficiently accurate models. For random research, we first define set of hyperparameters and such criteria to fine-tune our models because there are many hyperparameters with their values and we want to find an optimal combination to maximize our model's accuracy. We can specify how long we want to run the research. Individual models are tuned using cross-validation. Two stacked ensemble models are trained, which are all models ensemble and best of family ensemble. All models ensemble is all the models that you trained in the AutoML process. If you run for longer time and there are hundreds or thousands of models trained and we might not want stacked ensemble to be trained for all the models, then we choose best of family ensemble, which are best GBM, best GLM, best DRF, and so on. And finally, we will return a leaderboard of all models and can be easily exported to production. Now let's have a Orion sample use case, which is prediction of lower back pain severity. The dataset contains information regarding symptoms of lower back pain and severity like pelvic incidence, pelvic tilt, class attribute, and so on. The class attribute column contains binary values which are normal or abnormal that we are going to predict. The application is used to predict the severity of lower back pain, whether it is normal or abnormal, by considering different symptoms of a person. Now let's have a quick demo on predicting the severity of lower back pain using H2O AutoML. Here is the dataset which contains lower back pain symptoms and the severity with 12 numeric predictors and one binary class attribute. Implementation of AutoML can be done by using Python code and also can be done by using H2O dashboard. Here is the Python code for implementing H2O AutoML. Here I have taken lower back pain dataset and split it into test and trained datasets by considering 82:18 ratio. Here I have taken class attribute as output column, which is normal or abnormal as I am going to predict, and taking rest of the columns as input columns. Here I am training the model by taking input and output columns and also consider some of the parameters which are max runtime seconds, where the model is going to run for 90 seconds, and I have specified max models as 10, where it takes 10 models out of all the models in the H2O, and seed value is 7, which is used for reproducibility so that the same results will be produced when training data and other factors are same. Here is the leaderboard of top sorted models, and out of all these models, generalized logistic model is the best model, which has highest AUC, which is 92. AUC is the percentage of area under ROC curve. Generally, ROC curve visualizes the performance of binary classifier. It is a trade-off between two true postulate and false postulate at different classification thresholds. Here is the graphical representation of all the models. Here I am saving the model and predicting the output. Here is the class attribute of the test dataset, and here is the predict column which I have predicted. We can observe that the outcome values are almost similar except for few values. Here is the H2O dashboard. I have created a same model with the dashboard too by using AutoML functionality. Here is the leaderboard, and here is the generalized logistic model, which is the best model, which has highest AUC, which is 92. Here I have predicted the generated model by uploading the test dataset, which is 18%. Here I have combined the results with the data frame, and here is the outcome. Here is the predict column which I have predicted. And here is a class attribute which is available in the test dataset. We can observe that the outcome values are almost similar except for few values. So in this way we will create a AutoML model on H2O dashboard. Thank you.
Thank you for watching a video on Insight Hub. The video series brought to you by Miracles Data Practice. For more videos, please visit miraclesoft.com/insighthub.